All right, last but not least, category 5, exponential functions. So we've done linear, we've done quadratic. This is exponential, where the x is literally the exponent. So exponential x is the exponent. All right, what does that a represent? Remember, that is your initial value. So what are you starting at? The b, so it's usually either in parentheses, or it could also be written just a times b. You might not see parentheses, but a lot of times it's in parentheses. That b is your growth or your decay factor. Okay, if we break that down, growth or decay, if the b is greater than 1, it's growth. If the b is less than 1, it's decay. Another option, if you're not quite sure, is you could always take the equation they gave you and graph it in the calculator. Growth is getting bigger, decay starts big and gets smaller. Okay, if it ever asks for an exponential model, an equation, a function, remember if it's giving you a table or points, you can go plug those into stat edit. And then for exponential, you would do stat, calc, remember exp, exponential, so number 0, exponential regression. Okay, and we had some more vocab. We had what's called an asymptote. Remember, there's always an invisible boundary line where your graph is starting to level off. So you can, in this case, look, it's never quite crossing over the x-axis. So remember, asymptote is your boundary line. It's always y equals. So in this particular case, it would be at y equals 0. Okay, y-intercept. It's always where x is 0, so we'd be looking for this point right here. Now I can't really see that with the scale from this graph, but I did give you the equation. So if you wanted to, we could go quickly to, let me clear the memory of what I was doing earlier. And go to y equals, and I'm going to go ahead and type in the equation I gave you. So 2, parentheses 2, and remember, if you want to make an exponent that's not just squared, there's this little caret button right here. So you'd push that, and it makes an exponent, and you would just put the x in. Okay, so then if I want to try to do y-intercept, I would just go second table, and we know it's where x is 0, so 2. So in this particular case, it's at 0, 2. Now the faster way to do this is that number is always going to be your initial a value. So this right here is also just that a initial value. Okay, because again, initial, where is the graph starting? All right, domain, if you're looking at a true function where it's going forever, right? That's where we get our all real numbers. The range, however, since we do have this invisible boundary line, it's never crossing over to the other side, so it's never going to get into these negative numbers. It's not all real numbers. It's all above our asymptote, and the asymptote was y equals 0. So the range in this case would be y, and then all the numbers greater than 0. If the graph was all down here, below the asymptote, then I would have put y less than 0. So if it's above the asymptote, greater. If it's below the asymptote, less than. Okay, and then let's do a few quick little practice problems. On this one, you're just trying to set up the equation based on the problem. So again, you're looking for initial value and then growth or decay. Greater than 1, less than 1. Okay, in the first year of production on a new running shoe, a manufacturer produced 10,000 of the new brand. So first year, 10,000, that's your initial value, so this is your A value. If you look at the choices though, that doesn't narrow anything down because they all have that for A. Okay, so let's keep reading. Sales skyrocketed, and for each of the next several years, shoe production went up by 5.5%. So up means we're growing. So if we go back over here, if it's a growth, that means that your B value, that number in the parentheses or the number that's right after the A that has the exponent, is a number bigger than 1. If I look at my choices, if it's growth, we're looking for a B value greater than 1. These two are both less than 1, so these would be for decay. So I'm going to get rid of A and B. Okay, now I have to narrow it down to which one of these is by the right percent. So if it's going up by 5.5%, I'm hoping that C looks pretty obvious because you can see that 5.5, but let's just go over it one more time. Remember, if you have a percent, you move that decimal back twice, okay? And you always start with 1. If it's growth, you're adding. So if I do 1 plus 0.005, let me just say 0.055. Oops. You get 1.055, which is, again, what C has. So C is our answer. Okay. 9E, exponential regression. Write an exponential equation to model the following data. So this is just a straight stat edit problem. If you want to pause the video and try this on your own, that would be a great idea, and you can come back and see if you got it right. But you're going to plug all this into your calculator. So let's just do that real quick. Stat, edit, all the x's, so 2, 3, 4, and 5, all the y's. Make sure you didn't forget a digit. That's always an easy thing to do. If you get some sort of error message, you always want to come back here and make sure you typed it in perfectly. If you get weird numbers that don't match mine, then you probably forgot a digit somewhere. You typed something in funny. Okay, so you go stat over to get to calc. And then this is where you have to decide linear, quadratic, exponential. So since we're doing exponential, look for 0. Enter, 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 enter. And then you're going to write your equation. Okay, it will even remind you of how to write the equation up here, right? So A is 0.2, so A, 0.2, times B, 5, and then a little exponent of x. So it'll be y equals 0.2. Now, times 5, you can do the dot. I like to do the parentheses, exponent. There you go. All right, last but not least, domain and range. So we've talked about in the past, domain we know is x values, range is y values. So when I'm reading through this, the population of a growing town is modeled by the exponential model P of t. So that's really where our y is. So this is our y, and that is the population. P for population. Okay, equals 104, so that's our initial starting number, times 1.0016. So since that's bigger than 1, we know it's growth, and it even said growing up here. And then power of t. So t is the number of years. So that is our x, and it's years since 2010, which best describes the domain and range of this exponential function. So all the domains where they say t, we're talking about number of years. All of the ranges where it says p of t, we're talking about the population. Looking at the choices, I see a lot of zeros, and I see a few 104s. The 104 is coming from that initial number. Here are some ways you can start to narrow it down. Most of these symbols say greater than, except for this one right here, and this one right here says less than. So think about what this one's saying. Range, P of t. Remember, that's population. That's a number of people. The population is less than 0. That would mean that you have negative people. Negative number of people. And that does not make sense. So that would not be the answer. Now, this is not quite the same thing because it's saying less than 104, but that means you'd have 104, 103 people, 102 people. That's all okay, except it said it's growing. It should be getting bigger. Also, eventually, this will get to 0 and then negative numbers, so that also doesn't make sense. Okay, so if we're focused on what we have left, we have 0 for time, 0 for time. Both of those kind of make sense for years. Okay, the range is the big difference. We've got the range starting at 104 people versus starting at 0 people. Okay, well, think about what I just said. Starting at 104 or starting at 0. The initial value of people was 104. Okay, the graph, the population of this little town started at 104 people and it got bigger over time. So it wouldn't make sense to start at 0 based on what they told me up here. So based on all that, the answer is B. If you wanted to try to graph this in the calculator, and you can kind of look at the graph like this, you can. That being said, 104 is a large number, so you would definitely have to sit and play with the window for a bit, so it's a little hard. Actually, here's another option. If I do plug it in, so they give us 104 times 1.0016, make your exponent. Like I said, you'd have to mess with the window to see the graph, but here's another option. You go to the table. Okay, there's our starting number. The y is starting at 104. If I back this up, this doesn't really make sense with our scenario because we can't have negative years. So I know this is getting smaller, but that doesn't make sense with our scenario. So if I'm starting at 0 years, the lowest possible population was 104. And as I get bigger, it's only getting bigger. It's not ever going to get down to 0. So if you wanted to use the calculator, you could try to use the table. That might be helpful. But biggest thing is you can't have a population of 0 since it started at 104. All right, that's it. Finish up your assignment. So show this to me. Once you showed me the filled out notes, I'll give you the assignment. If you finish the assignment early, you can work on Edpuzzle, and that's it. Let me know if you have questions.